Welcome to the ML Platform Podcast, brought to you by Neptune AI. In a show where Piotr and Arimas, together with top MLOps practitioners, explore the world of internal ML platforms and MLOps stack components. Today we've brought Chaoyu from BentoML to talk about model serving, deploying LLMs and everything production deployment.
The challenge today is even you get all the parameters and weights for the Llama 2 model, it's very challenging to run it efficiently. Or even being able to run it across multiple GPUs and utilize all those resources. One thing is at which point you start seeing the benefit of using such a system, right? And I think that typically comes when you are thinking about deploying something that needs to serve production traffic.
Now onto the show.
Hello everyone, and welcome to Machine Learning Platform Podcast. I am your host, Arimas, and as always, together with me, I have my co-host, Piotr Nedved, who is a founder and CEO at Neptune AI. And today, with us as a guest, we have Chaoyu Yang, who is a founder and CEO at BentoML. I think it will be a very, very nice conversation because we didn't have any other guests that is so deep in model serving and deployment. Hi, Chaoyu. Could you maybe introduce yourself to our listeners?
Yeah, absolutely. Very happy to be here. My name is Chaoyu. I'm the founder and CEO of BentoML. At BentoML, we provide the tooling and infrastructure for AI teams to build AI applications, which including serving models as well as applying the business logic required to apply models to business problems. We have a growing open source community. You can find us on GitHub and try out our open source products for serving AI models in production.
Yeah, I wanted to start. With basic question, just for us to share common understanding what serving and deployment component really is, and from product perspective, what are typical jobs to be done that you can expect components, serving and deployment components can bring to your MLOps stack?
I think from job to be done perspective, it usually comes down to after data scientists have trained the machine learning model, or if you are taking a pre-trained model or fine-tuning the foundation model, and then with a good result in the testing data set, now you're thinking about applying that in your application, which typically means you want to have other applications or end users being able to access this model, typically through an API or being able to run the model in the batch inference job. So you'll be able to access the result from the model. And in order to do this in a production-ready setting, you need to have all the infrastructure and models to be highly reliable. You need to control the latency, as well as thinking about the cost of running those models in production. And I guess deployment side, it's more about the end-to-end workflow of getting your model from the training environment, development environment, into something that's running, for example, in the cloud, and have like a more powerful GPU, for example, to offer low latency.
And when it comes to packaging, would you also include this into this unified package or like bundle of things, or is it a separate thing for you?
Yeah, that's actually a very important concept in the BentoML product. And that's also where the name comes from. BentoML offers a standardized packaging format for developers to package everything they need to run the machine learning model in production. Think of it as the container, Docker container, but for AI applications. It contains all the model files, all the source codes required, as well as the configuration for its environment, dependencies, CUDA library versions, etc. So with this standardized format, on one hand, we provide SDK for developers to build applications, to decide what model they need, package them into this bento format. And then on the other side, we provide different toolings and different runtimes for running the bento in different environment.
You said think about it as a Docker container for ML or for AI. So how is it different? Like when we look just at the packaging piece. So what you need, what you add on top of what Docker can do for you. Why you need, everybody use Dockers, right? Why we need something else?
That's a great question because it has to do with downstream applications, how you're applying those models, right? The traditional web services, for example, it's fairly standard way to deploy with Docker. You run one process per container and horizontally scale them. But AI applications can be quite different. For example, BentoML offers a Docker container mode of deployment, but that's usually not the most efficient way of deploying AI applications. For example, in our commercial platform, Bento Cloud, when you're deploying the Bento, it actually spins out to multiple different type of containers. Let's say I have an application that's running multiple models, and I can put the most heavy and compute intense model on a large GPU, whereas I can put some of the I/O bound, let's say fetching features or fetching vectors, as well as some pre-processing step on a different CPU node. So being able to have this more standardized format defining what an AI application need allow us to have more flexibility down the line, deciding how you actually use container and container orchestration technology to deploy your workloads more efficiently. Another example would be taking the same Bento, besides the online inference, online deployment, you can also apply it to run a batch inference job, for example, on platform like Spark or Apache Ray. Sorry, I guess Ray is not Apache. But yeah, those different downstream applications actually help us define what needs to be in the Bento and what are some of the standardized interface we need to define there.
So if I hear correctly, it's not only a single model, but rather the entire model chain or model ensemble that you can define in BentoML.
Mm-hmm. That's correct.
BentoML takes care of all of it, right?
Yeah, BentoML will take care of essentially the infrastructure layer that's needed to run that type of multimodal application more efficiently.
Do you provide some automation around it? Like, do you use maybe some machine learning for optimizing your applications as well? Or is it more manual and the user himself or herself has to define like which infrastructure to be used for a specific piece of your, let's say, model ensemble?
I think just like most infrastructure software these days, most of those decisions are based on heuristics. I don't think we're really applying AI ops here to do it more smartly, but maybe that's something in the future we can look into, because that's very important for us when we build out our entire cloud platform for deploying large amount of models and AI workloads. Being able to utilize the resource more efficiently is key to the value we provide.
But how do you, like when you say heuristics, is it something that a user of BentoML has to provide, or is it something that you kind of automatically infer from the composition of application to choose what infrastructure to use?
Yeah, it's a combination of both, I would say. So I think today, most of the case, we will try to come up with a good default, but then we give user the full control on a lot of aspects, like how fast you want things to scale up, or how much resources each model will require when running and deploying things in production.
And when it comes to cases where you to do particular inference, you need to use a chain of models. Let's call it a DAC. Do you also have this kind of concept when you're packaging those models, or they are rather independent models and something else needs to coordinate the DAC execution?
So in terms of BentoML, the framework, it basically allows users to define their logic. For example, sometimes you may want to run multiple models sequentially. One model's output becomes another model's input. For example, an OCR application that recognizes all the text in the PDF file and then send the text to a downstream NLP model. There are also cases you may want to run multiple models in parallel. For example, fraud detection case, you have 10 different models looking at different features, making decision, and then you join the result to make a final decision. Right. So BentoML offers ways to describe those type of business logic. And then in the final packaging, it includes that business logic as well as all the model files required. And then in the deployment side, it will be able to utilize those information and decide what's the optimal way of provisioning things in the cluster.
And what about models that are quite popular now, that cannot fit on one machine? Do you also support deployment setups where one model is actually distributed?
That's a great question. Yes, that's a very important use case for BentoML. We actually have a blog coming out very soon, collaborating with Hugging Face, that describes how you can utilize multiple GPUs to deploy a large text-to-image generation model. A lot of those configurations, if you want to do it manually or implementing it yourself, can be quite cumbersome and time-consuming. But with BentoML, you can fairly easily experiment with different setups.
Okay, so we covered cases that I would say are maybe more complex. So we either have a lot of models, or we have models that are like to really do the like OCR, right? That we need to have sequence of models or do it in parallel, or we have really big models that cannot fit in on one machine and we need to have distributed inference. There are more complex, more setups. What about standard setups, like simpler setups for a startup? And I'm getting to the point when you feel component model serving, model deployment component in general is needed. When as a, let's say we are ML platform team, and yeah, how I would know that it is time to consider such component in my stack?
That's a great question, because I think it has two components to it. One thing is at which point you start seeing the benefit of using such a system, right? And I think that typically comes when you are thinking about deploying something that needs to serve production traffic. You actually have requirements on the throughput, the latency. You're looking to scale the workload to serve more users. So you care about, per GPU or per CPU core, how many requests I can serve per second. Is it going to waste all those expensive GPU resources I got and don't care about AWS bill at all? Or do you actually want to have an optimal infrastructure that can save you cost and gives your users a better experience?
Even Lambda functions like, deploying serverless function. I don't know whether they support GPUs or not. Why not doing it like that? It also scales, right? Horizontally.
That's a great question. I think in theory, I think any of the DevOps or cloud platform, you can apply it and to scale it. Of course, there's another extra layer that you need to build on top, and that can become quite complex. Let's say you're using a serverless platform with GPU to build a model inference application, right? Oftentimes, what we see is people have a Python script that first does some of the pre-processing, maybe fetching data, and then runs a pipeline that's the actual model inference. But because of limitation with Python, when the CPU part is running, the GPU is just idle and waiting for execution. For this kind of simple, naive setup, if you just deploy to production, you will see your GPU utilization can be consistently low and oftentimes even lower than 20%. So you're wasting a lot of money buying GPUs that you're not fully utilizing. So of course, there are many different ways and tricks you can implement things to make it more efficient, but that quickly becomes a very challenging backend project that most teams, let's say you have a couple AI engineers who's deep into research and AI models, they probably don't have those expertise of applying those backend infrastructure tools to make it more efficient. The entire setup can become a lot more complex as well. You're looking at using Terraform to create multiple different lambdas, being able to serialize the data between them more efficiently. Whereas in our view, that whole process should be streamlined because there are so many more engineers coming into this space and are building AI applications on top of models. So I think the necessary infrastructure for scaling is there. We just need to make it more accessible for AI application developers.
So I actually didn't know that, but maybe it is the Lambda thing, Lambda limitation that you cannot fork your process. So use multi-processing library in Python to use CPU and GPU at the same time. I didn't know that you cannot, because in Python you can, I would need to check, but I don't see a reason why I couldn't use Python and GPU and CPU at the same time. But yeah, I would use multi processing library to fork my.
The core problem here is a lot of those compute can have IO bound, CPU bound, and GPU bound, and mixing them in one place will increase the complexity.
Does BentoML solve, like the open source part of it? Does it solve for it, or is it only the cloud offering that you provide, like solves all of these issues that you are now talking about?
I think BentoML open source solves some of those problems. So the way we think about our open source versus cloud is that BentoML open source offers most of the necessary components for building AI applications. We do have a cloud native offering that runs on Kubernetes and does this kind of distributed deployment, but definitely requires deep knowledge in DevOps and Kubernetes to actually operate that in production. But with our cloud product offering, we kind of offers all of those with additional, collaboration, performance optimization features on top. So developers don't need to worry about that infrastructure layer at all and focus on building the AI apps.
Even with open source, one would be able to deploy kind of, let's say, tuned down version of your cloud offering on top of your Kubernetes clusters?
Yes. If you have a DevOps team.
Okay. That's nice.
And what about, because we hear more and more need for it, more of our customers and leads ask for on-prem deployments because of the regulations. How does it look from your perspective?
Yeah, I think for us, it's fairly straightforward to support for on-prem. I think a lot of the challenges comes from if you need extensive support for different GPU types, that setup can become quite complex. But in terms of most of our infrastructure and technology, it works fairly nicely with on-prem infrastructure as well. Most of our infrastructure nowadays are built on top of Kubernetes with a lot of our extensions. But I think most of the company's focus today is helping our users to get their workload running in the cloud. For some of the more regulated industries, another thing we do is helping to deploy those workloads into our customer's cloud account. That way the model and the data never leaves the customer's VPC, but then they have this entire cloud automation that works out of the box without us dealing with the complexity in the on-prem environment.
How does it work with large language models? At the same time, I had a feeling that when you said that it is not just about packaging and deploying one model, but we are also talking about the concept of dependencies, right? Like you said, sequential models, or then I feel it's way more natural. But if you can share with us what you can do for people who are using large language models, and what are subcases of it, like people who are using large language models that are hosted by cloud providers or vendors like OpenAI. What about guys who are using open source large language models and need to host them themselves? Do you support these use cases? And if yes, how?
That's a great question. I think today BentoML supports actually both type of use cases, but I would say it makes more sense for the second use case where the OpenAI's API doesn't work for your scenario, either for privacy or cost, any of those concerns. You need to fine-tune and host your own large language model in the cloud. That's something BentoML can offer tons of value. So if you're just looking to deploy an endpoint that looks similar to OpenAI's large language model endpoint, we actually have a new open source product called OpenLLM that supports pretty much any of the popular open source large language models. And we optimize the process to turn the large language model into a bento, offering an API that's compatible with OpenAI API, and offers native integration with popular large language model application frameworks like LangChain, Llama Index, or Hugging Face Agent. So you can very, very easily build those applications on top of an open source language model, as well as packaging everything together for production deployment.
And when I use BentoML Cloud for it, let's say I'm your customer, okay, and want to have one of the open source models for me, will I need to, do you share the infrastructure between customers to host those models? Because they're quite big, right? Or each customer gets, let's say, dedicated version. And if yes, how much does it cost to host, let's say, ChatGPT 3.5 comparable quality open source model?
I think it really depends on a couple other factors, like do you care about latency, right? Token per second, if you need to get to close to that quality. So I think a lot of, depending on the use case, if it's chat use case, a lot of time people do compare it with ChatGPT 3.5 in terms of the cost. But more often we're seeing enterprise use cases where you're looking at a domain-specific problem. You don't need a large generic large language model that knows about everything in the universe. You just need to solve this one specific business use case. You need to run at scale, so you care about latency and cost a lot more. So those cases, more often we see people looking to fine-tune a much smaller language model and apply it. So in those cases, you obviously will get way more cost efficiency compared to something like ChatGPT 3.5.
Out of curiosity, do you know what was the most expensive, let's say, pay per day model to host that BentoML hosted when it comes to infrastructure cost?
Sorry, not top of my mind. It's probably we haven't seen anyone that's using like a language model that's more than 60 billion parameters, for example, like heavily in production. So a lot of time our customers are using our serverless component, where we only charge them by the amount of compute time they actually use. But I think with the new release of Llama 2, we are seeing a lot more excitement from the community. And I think some of those larger parameter versions of Llama 2 are quite production ready for many use cases.
What about other components that are also, like, from my perspective, close to serving and deployment component. One that maybe not, that is less straightforward close. What about feature store? We had a Michael from Tecton here a few episodes before, and I asked him why feature store wouldn't host models. Why we wouldn't think about, a model like inference as a feature development, as a feature calculations. What is your take on feature stores and potential? Do you need both? Do you also, like, when we look at Bento, do we also do pre-processing as a part of model execution? If not, why not?
Yes, we do. But I think there are certain limitations, especially if you're thinking about time series applications where you need to do large joins. Those are cases where a single process or a single machine data preprocessing won't be able to fulfill the needs and do it in a real-time manner. So I think it really depends on type of application. If you are already working with large-scale data set and the feature calculation actually needs complex joins and complex preprocessing, then the feature store definitely help you simplify that process, both for, during training time, access those features in the batch mode, as well as when you're serving in production. So BentoML does offer a native integration with some of the open source feature stores. And it's also not too hard to integrate with the commercial feature store for, deploying and accessing real-time features. But there are also a whole other type of AI applications. The data preprocessing and the transformation doesn't really necessarily need to access a lot of data, right? For example, you're just preprocessing image, for example, right? So those are the cases where BentoML's architecture can help you run that type of workload most efficiently.
But is it also like the preprocessing of data also takes time, regardless if it's a big join or just few records, right? So I guess feature store can also be leveraged in that case, right? If you only want to pre-process once.
Kind of to cache results is what you're saying, or?
Yeah, exactly. Exactly. Like additional reduction in latency, or do you think it's not worth it?
Why not to have caching on the level of model serving?
And I guess also when you're working with NLP or image processing, it's fairly hard to say, I've seen this image before, I will use that cache, right? So I think for large language model, there are some semantic caching things people can do, but I don't see that very common in practice.
Another component then, model registry.
Yeah, that's, I think especially for data science team who needs to frequently retrain their model, that's a very important component, right? I think one of the biggest problem in after a model hits production is you want to go back and see, which data set did I use to train this model, right? Which version of the source code I did, if you need to troubleshoot certain issues and figure out ways to improve your model, or for regulation reasons that you need to tell the end user exactly what data set you used. As well as in the development workflow, when you are trying out a bunch of different ways to train the model, different parameters, and then exploring which one provides you the best model.
But there is kind of an overlap, okay? So when we look at model registry, like I see a few functions, and I see some of the functions like you mentioned. I want to understand how this model was built. What was the data set created? We can always associate with, I bet that BentoML has some registry of those Dockers, those models, and those bentos, and I also bet that you can add some level of description, some small metadata around it, maybe a link to experiment tracker, which experiment it was, and then you will know. but model registry also very often allows for that. But model registry components sometimes has information about the stage where the model is. Is it on the production staging or not yet deployed? Sometimes people ask, okay, should model registry orchestrate the deployment strategy? In particular, let's do some canary tests, etc. Do you see this part? Let's say we want to release a new version of a model, but in a safe way. Would BentoML do it for me, or I need to have another component that would orchestrate this deployment strategy?
Got it. Like the end-to-end, like updating the model to production and for data scientists.
But in a safe way. So let's say we want to move 10% of the traffic to the new model, 90% to the previous version of the model, and over the time increase it to 100%.
Yes. That's something supported in BentoML. I guess what we don't do is kind of a model repository where you can move a model from one stage to another. We're going with a more approach that's focused on the CI/CD pipeline. So on one side, we actually integrate with any of the model registry providers. For example, you can be uploading your model to Hugging Face Model Hub and then pulling down from there, or some of the open source libraries that does experimentation tracking. And then once you decide to promote a model from there, you can trigger a job that either managed by GitHub Actions or running that on Bento Cloud that can listen to those events, those changes, and triggers a rebuild, pulling down the model, rebuild a new Bento, and deploying to production. And then you can choose the canary strategy, 10% to your model, and observe for the result.
You need to also, to support those use cases, I'm thinking at what level, how low you go with Bento. When we stay on the Python function level, the abstraction is simple, but at the same time, you have limited options what you can really do with your infra because you don't understand what is happening under the hood, especially in the case of distributed setup. So can you tell me how low you can go? Maybe I should have asked this question at the very beginning, but how do I upload a model? How do I create Bento, right? The image of a model. How it works in practice?
Yeah. So we provide a high-level Python function for you to define the service, what are its APIs, what are the models you need, and then as well as the business logic of applying that model to a specific input data set. And this kind of service that you define, you can easily spin it up locally and test things out. And once that's ready to go, you can do BentoML build, which creates a new Bento that's ready for deploy.
And what about situation when my model needs to be run on few machines?
Yeah. I think that comes down to an abstraction in BentoML called runner. So we provide pre-built runners for many different AI frameworks, as well as for some of the more complex models, we provide a more sophisticated implementation. So it depends on the type of model.
Framework I use.
Yeah.
Right? Like TensorFlow. Mm-hmm. In distributed setup, I would need to use the runner that is able to run distributed TensorFlow model. Is it right?
That's correct. So a lot of time it's actually one runner that controls multiple different shards of a model across different GPUs. But then BentoML at the scheduling layer, it knows that this runner will require, say, 4 different GPU resources to run. I guess you touched a bit earlier, like how low level we can go in terms of optimizing things. I think that's very interesting because we, on one end, we offer this Python high level API. The reason for that is, of course, developer experience, right? This is where you're concerning about the business logic, the data flow, and how you apply that to a problem. And Python is perfect for that. But then if you're just running a normal Python script, it doesn't give you too much room for optimizing things, unless you want to rewrite everything in a different language and do all sorts of lower level things. But because BentoML introduced a couple concepts in there that makes it fairly able to abstract away the model inference component. So under the hood, we can actually support more efficient runtimes. So for example, you can run the model part completely without Python with, for example, Onyx runtime. We even support Triton inference server from NVIDIA for running each model. So in those cases, BentoML serves as the orchestrator of that business logic and different model component in your application. With some of the large language model, for example, even though it's still Python based, but we can still able to do things like custom CUDA kernel or some of the more optimizations around the model's architecture to make it run faster.
So it is not limited to Python. Like Python is more how to define on higher level, but you can define also.
That's right.
On a lower level. Mm-hmm. So I see now why it's needed. But at the same time, I feel that when did you start as a company?
We started around, I think, April, May 2019.
Like I had a feeling that it is type of a product and a company that is quite challenging to build at the beginning, because it takes time to, cross get to the point where what you build brings value versus the benchmark. The benchmark will be, let's say, Lambda, right? AWS Lambda. And also when it comes to customers, because like when we were thinking about Neptune and what we should do, because we saw a lot of problems in MLOps. Okay, at that time it didn't have the name MLOps, but had a lot of problems. Data scientists were dealing with building, deploying. We thought that it would be good to start rather earlier, because at least amount of people that are at this stage would be bigger than amount of people that are already deploying models. Today, I think it's a little bit easier, but when you've been starting, I think it was, we had an easier time. So how did you find your first customers, if you can share it with us?
I agree. Looking back, I think the time when we started, the market doesn't have a strong need for that yet, or our product was a little bit too early to offer enough value. But yeah, I think after kind of few years working with the community and keep improving the product, we are now at a state that we can fairly easily convince a customer, here are the values we provide, reasons you should adopt. The way we find our first customers is actually also through open source. I think in the earlier days, BentoML framework is not offering all those values we have today. But at least for some of the simple use cases, it gets things done much easier in a simpler way. And we were able to attract contributors and users from the community and have the opportunity to speak with them, learn about other challenges they're facing after they've built a bento, and sort of develop our early customers from those open source adopters.
So from retrospective perspective, it sounds like you do not regret starting open source, or maybe you do?
No, I think it's a good decision to do open source. Yeah, and it takes a little bit luck there as well. I feel like it's pretty hard and time consuming to run and operate the open source community. But I believe a lot of the product insight that our team learned through the past 2-3 years are all coming from working with those open source users.
And do you remember how did you attract the first contributors? Not people who downloaded and add a star, but who really contributed something useful.
Honestly, I don't think we did anything there besides putting the project out there. People find us, they try to use it, they run into problem and submit the pull request. I actually love that about the open source community. People
But any marketing needed or nothing?
We were not doing any marketing back then.
Add an open source license to your repo and wait?
Pretty much. In the early days. Of course, we probably shared with a couple of friends for them to try it out initially. And then some of them help share in other groups so people find it.
Okay, so before we actually close our episode, Chaoyu, maybe you want to leave our listeners with some thoughts of yours.
We kind of covered a lot of topics today. I feel like large language model is something everyone is asking for. Both Neptune team and BentoML team are investing heavily there. I would say definitely check out those new features. I guess Neptune team is building, and on our side is Open LLM project if you're working on something large language model related. And yeah, feel free to reach out to me on Twitter. You can find me by searching my name or BentoML account.
Thank you, Chaoyu, for being with us. It was an amazing chat. And of course, thanks to everyone who was listening, and see you in the next episode.
The ML Platform Podcast was brought to you by Neptune AI. If you would like to learn more about ML platforms and MLOps, check our blog at neptune.ai/blog. Follow us on LinkedIn or subscribe to our YouTube channel. Also check out how we help teams solve MLOps challenges with our experiment tracking at neptune.ai. To get notified of future episodes, follow us wherever you get your podcasts. Thanks for listening, and see you next time.